Hello, good day everyone. My name is Richard Chandra. I'm from Corporate Finance class from IPMI International Business Schools. In today's opportunity, I will tell you a bit more about statistics. And one of the tools from the statistics is multiple linear regression. Before start, allow me to introduce my mentor and lecturer, Professor Roy Sembel. Go to the quote from Unreached Dunkels. It says that it's easy to lie with the statistics. It's hard to tell the truth without statistics. This is the total mind mapping of multiple linear regression. In the left side, you can see the general information, and in the right side, you can see the assumption test and the correlation. I know it looks like a complicated one. I do agree. But in the next 10 minutes, I will make it simple just for you. Alright, let's start with the general information first of the multiple linear regression. The multiple linear regression is a statistical technique that is used to predict the outcome of a variable based on the value of two or more variables. So that's why it's called multiple, right? If only one variable, we can simply use a simple linear regression. The purpose to determine a mathematical relationship among several random variables, and the mathematical equation is the y of this, let's say the mathematical equation, the y represent of the dependent variables, and the x is represent for the independent variables. The beta itself is for the coefficient, and the I is for the time intervals, and the E is for the errors. For the data collection itself is divided into two. So one is the dependent variables, and second one is the independent variables. Dependent variable only one, but independent variables can be 2, can be 3, can be 4, can be more. Alright, let's go for the example of the case here. So the purpose of this case is to know the influence of the financial performance ratio, the IHSG stocks return, and the USD to IDR rate returns towards the INKP stocks return. So in this case, the dependent variables will be the INKP stocks return. INKP stands for Indakiat Pulp and Paper, one of the stocks that listed in the Indonesian Stocks Exchange. And the X, we have 6 independent variables. It's from the CR, ROE, TAFT, DR. 4 of this is from the financial ratio of the liquidity, profitability, activity, and the leverage financial ratio. X5 and X6, as mentioned earlier, is for the HISG stocks return and the USD to IDR rate of return. The sample size is 40 samples taken from 2013 until 2022. So there are 10 years. Each of the year there are 4 quarters. Means that we have a 40 samples data from this study case. The equations from this study case is this one. So the y of the dependent variables equals to the 6 independent variables with each of the coefficient. Alright. So this is all about the general information of the multiple linear regressions. I hope that you are all still with me. Let's go to the next one. Okay, before we can analyze the data, we need to do the assumption test first. The assumption test is needed to ensure the data is not biased, the data is accurate, and the data is persistent towards our confidence level of 95%. Means that we can only allow 5% degree of errors. Let me also remind you that all of this test is using the SPSS statistical software. I do hope that you have already in your laptops and you can go following me towards the assumption test and the correlations by your own. Okay, assumption test. There are 4 steps of the assumption test. We go for the first one of the normal distribution. There are 2 ways for the normal distribution. One is a graph and the second one is Kolmogorov-Smirnov test. Normal distributions is to ensure the data is not far from the data average, not far from the data mean. From the SPSS software, put all the 7 variables one dependent variables and 6 independent variables. Remember, there are 4 that taken from the financial ratio, and ensure that in the column measure you can click on put it all scale. There are 40 generated data and 7 columns that generated in the each of variables there. Okay. In the SPSS, you can click Analyze, goes to the regressions, and goes to the linear. After that, pop-up window appear. Put it to correct dependent, 1 dependent, and 6 independents here, and then you can click Plots. Another pop-up window will appear, and for this pop-up window, ensure that you can click the SRASID in the Y. This is for the studentized residual, and click for the ZPRED in the X-axis, which is this is for the standardized predicted value. Then you can click both histogram and normal probability plot, then click continue. There will be a graph like this appear, and means that if the graph shows a bell curve asymmetrically like these pictures, means that the data is normal distributed. And for the second picture, it shows that from the line, means that all our 40 samples data is near this line. There is no sample data here, here, or even there. So it means that all of this data is normal distributed. Okay, the second way is to do the Kolmogorov-Smirnov test, or we can call it KS test. The KS test is the same approach. We can click Analyze, Regressions, Linear, and then put the correct dependent and independent, but in this case you can click Save. Pop-up window appear, check Unstandardized, and then click Continue. There will be another column appeared in your tables, which is called Residual 1. Again, Analyze, Non-Parametric Test, Legacy Dialogues, and click Sample KS. One sample KS. Put it here. The new column, just drag it to the right side for unstandardized residual, and then click normal and click OK. There will be a result coming in, and if you can focus into the bottom row, which is this is called asymptotic significance for two-tail, it called appeared the value of 0.2, and 0.2 is bigger than 0.05. Means that the data is normal distributed. Again, where is 0.05? 0.05 is our degree of errors. In this case, 0.2 is bigger than 0.05, means that the data is also normal distributed. Okay, after we pass the normal distribution test, then we go to the second test, which is multicollinearity test. Multicollinearity is the occurrence of high intercorrelations among two or more independent variables. There are tolerance and the VIF value that need to be passed for this test. Multicollinearity. Go to the Analyze, Regressions, Linear, and then same with the previous one, one dependent and six independents, and then this time you can click Statistics. Make sure that you check the collinearity diagnostics and then click Continue. There will be a pop-up result for the coefficients tables that appears in your SPSS software. And then you can focus on the two right columns here, which is this is for the tolerance and for the VIF. So to ensure that we pass this test, you need to check the tolerance. All of these 6 independent variables all need to be above 0.1, which is if you look into this case, all of our data here is above 0.1. And go to the VIF, and VIF is the variance inflation factor. All the 6 independent variables also need to be below 10, which is here all is below 10. Means what? Means that for this test there will be no multicollinearity. And no multicollinearity, we make sure that we pass this multicollinearity test. Alright. Then we can go to the next steps, our third steps for assumption test, which is heteroskedasticity. Heteroskedasticity means that when the standard deviation of variable monitored over a specific amount of time are non-constant, we use the scatter plot. The scatter plot is what? The scatter plot is here. Same, creations, linear, and then dependent one, 6 independent. This time you can flip plots. And then same with the normal distribution test. You can put the SRI in the Y and set PRID in the X. Click continue. This is the pop-up result that will appear. And if you see that this line from the zero, you need to ensure that all 40 data is scattered around, whether that it's above or whether that it's under this line. Means what? Means that the data shows that no heteroskedasticity. Means what? Means we also pass our third assumption test. Okay, we go to the last assumption test called autocorrelation. Autocorrelation is the degree of similarity between a given time series and a like version of itself over successive time intervals. There are two ways to do this test. The first one is the Durbin-Watson, and the second one is the run test. Durbin-Watson and the run test is all situations. Means what? Means if you pass the Durbin-Watson already, you don't need to do the run test actually. Okay. Durbin-Watson is analyze regressions, linear, same. This time click statistics. This time you click Durbin-Watson. Make sure that you check Durbin-Watson. Click continue. There will be a model summary pop up like this, and then the right column, which here is the 1.5, is the Durbin-Watson value. After that, you need to know all the tables from the Durbin-Watson, ensure that you know with the alpha of 5%, which means that this is our degree of error, only 5%. And then from the Durbin-Watson, we know that the K is 6 and the N is 40. K is the number of independent variables and N is our number of samples, data samples. Here means what? Focus on the K in 6 and then we focus on the N is 40, right in the circles. With our value of 1.5 means that we are somewhere between 1.17 and 1.8 here. If you can see also here, our Durbin-Watson value is in between the Durbin lower value and Durbin upper value. Means what? Means that here the test is inconclusive. We need to do another test. Do not worry. We can do our next steps, which is we do the run test. For what? For ensure do we pass the autocorrelation or not. Autocorrelation test, here is remember the tables residual value that we have from the KS, Kolmogorov-Smirnov test. This time we click runs and then put the new column unstandardized residual in here and then click median. Then click OK. The run test will appear and then focus on the bottom row, which is called asymptotic significance for total. And here is 0.873, means that here is above 0.05, our requirement for run test. And here means that there is no autocorrelation. From that, we pass all 4 steps of assumption test. We pass, ensure that the data is not biased, the data is persistent and accurate. Now, let's go to analyze the data. Move to the correlation test. Correlation test is the heart of this mind mapping. There are also 4 steps to do these correlations further. The first one, let's dip into the t-test. The t-test is to determine whether an independent variable has an effect on dependent variable. There is 2 ways to do the t-test. The first one is the t-table, and the second one is the significance value of t. This is the OR situations, means if you can go either this one or this one, which one that is sure for you, and then you don't need to do this both. But again, for this video, I will try to explain both so you can have your, let's say, variants, which one that you want to choose freely. Okay, the t-test. T-test analyze regressions, linear, same, and then click OK. There will be a coefficients tables coming up, and you focus on the t. Here is the t value, and then make sure that you also have the t tables besides you. And from this one, we can see that the, let's say, the equations will be the alpha divided by 2, and then the n minus k minus 1. In this case is our alpha 0.05, not changed, divided by 2 becoming 0.025. Here is 40 samples minus 6 independent variables minus 1 fixed value, which is this is 33. And if you see the table here, that will be the 0.025 for one tail, and then goes below until you reach 33. There will be no 33. There will be somewhere here between 30 and 40. Means that you need to do the prorate mathematically, and then from this prorate between 2.021 and 2.042, it will be the prorate of 2.035. From the 2.035, this is we need to know which one that have the t values bigger than the t table. Our t table is here. So from this one, only the ROE, return on equity, which have the 3.267, which is bigger than the t table. Means what? Means only the ROE that have the significance value individually to the ENKP stocks return. Or and then go for the second try, the significance value of t. The significance value of t, the same tables that we did earlier, but now we focus on the right one. Previously focused on the t value, now the significance value. The significance value of t is under 0.05. This is the requirement. Means what? You can see, yeah, this one, and the other is above 0.05. Means the same result. The ROE has the significance influence individually to the ENKP stocks return. After t-test, the next will be the f-test. The f-test is to determine whether independent variables simultaneously have effect on dependent variable. So if the t-test is on only one single independent variable, this is all simultaneously independent variables, whether they have effect on the dependent or not. There are also two ways to do the f-test. The first one will be the f table, and the second one is the significance value of f. This is also the OR case, so means that the f tables, if you pass the f table with these requirements, you don't have to do the significance value of f. But here the case, I try to put it both tests into this video. Analyze regressions, linear, the same plot of the linear regressions, and then click OK. That there will be an ANOVA table that coming in. ANOVA is analysis of variance, and if you look to this column, the F means this is the F value. You need to have the F values for alpha 0.05 like before, and then if you look to this one, there are equations like this. So the k is 6, and the data minus the k, so 6 and 34. Mean that we have here 6 and goes bottom until you can find 34. So 34 is somewhere between 30 and 40. Means that if you do the prorate, you can have the f value of 2.38. If the f value bigger than f table, means that here is yes, because 2.4 is bigger than 2.38, means that all independent variables simultaneously have significant influence to the INKP stocks return. Right. To make it more clear, I go to the next one, significance value of f. Significant value of F is the same ANOVA table analysis of variance, but you look to the right one, significance. If the significance value of F is smaller than 0.05, here is 0.049 is smaller than 0.05. Again, the same result happens. All independent variables simultaneously have significant impact influence to the INKP stocks return. Means what? Means our 6 independent variables together simultaneously have a significant impact to the INKP stocks return. Next correlation would be the R square. The R square is to represent the proportion of the variance for dependent variables that's explained by independent variables in a regression model. The R square will take the same steps in the SPSS software, and then you can click OK. The model summary will appear like in these tables. You focus on the adjusted R square 0.178, which is 17.8% of this R square. Means what? Means all the independent variables simultaneously together only represent 17.8% of dependent variables. Means the other 82.2% influenced by other factors to these dependent variables. The next one would be the coefficient. Coefficient is the last part of this function. The last goal of this video is to form the mathematical equation. The steps will be similar to previously. You can click OK, and then the coefficients table will appear. In this one, you will need to focus on this B or beta or coefficient. This coefficient things, you need to form the mathematical equations via this one. So the dependent variables is equals to these coefficients, and then plus 0.089 from the first independent variables, and then plus this one minus third one minus again the third one, the TER, debt equity ratio from the financial ratio, plus 0.779 and minus 2.790. So the INKP stocks returns is equals to these mathematical equations from the first independent variables until the 6 independent variables combined into one. Right, easy, right? Okay, that will be to all of these mind mapping multiple linear regressions. I do hope that you can try with the other form of mathematical equations. You can choose your dependent variable. You can choose the other independent variables. The form is whether that's correlated. It's whether that what is the equation. It's whether that's mathematical. You need to know. That's okay. Don't worry to know in the left side the general information of this linear regression. The assumption test of those 4 steps of assumption test that need to verify your samples of your data to know that your data is not biased, your data is persistent, your data is accurate, and then you can go to form those correlations into the mathematical equation. Alright, so that will be the last from my side. Thank you for your attention. Thanks for listening these 20 minutes of videos. If you have any questions, feel free to put the comments below, or you also may contact me through my email here at richard.chandra@ipmi.ac.id. Again, thank you very much and have a nice day. Bye.